Hello guys, this is your instructor Mac and let's start off with the next lecture of IAS Unit 1 Mechanics and Materials. Well, in the previous lessons we have discussed about motion. We are done with general concepts of velocity time and displacement time graphs. Today we are going to be doing some combined concepts. This lecture is exceptionally good and very important. Might be the most important lecture so far, and then the importance of the lecture is going to continue with all the concepts being built up. So over here we have got a velocity time graph. In the first question they are asking you what is the total displacement of the journey. So in this part it's very simple. The first part they're asking about the total displacement. If you were to realize that the object is moving with a uniform velocity of 3 meters per second for the first 10 seconds, and then with a velocity of -6 for the next 5 seconds, this actually means that initially it was moving in a positive direction, and then after 10 seconds, the object was moving in a negative direction. This is what this graph actually indicates. So if you need the total displacement for the first 15 seconds, you are going to be adding the areas with respect to the y-axis. So you need to add these two areas. For example, for the first 3 seconds, if I were to get the displacement, so for first 3 seconds, the displacement will be 3 times 10. That is going to be 30 meters. And since it's a positive value because the object was moving to the right, so the first 10 seconds, the displacement is 30 meters. For the, sorry, for the first, not 3 seconds, for the first 10 seconds. All right. Moving on, for the next last 5 seconds. For last 5 seconds, again the area will be equal to the 3 is the -6 and then time is 5. So it's going to be -30 meters. This actually indicates that object moved to the right with 30 meters and then it came back 30 meters. So eventually the net displacement or the total displacement will be 0, because total displacement will be the sum of individual displacement, which will be 30 minus 30, which is going to be 0. This is the first and by very basic understanding of the graph. Moving on, if they ask you to make a displacement time graph for this journey, exact journey, and you were to make a displacement time graph, you would realize that initially the displacement time graph would be somewhat like this. Why? Because there is a uniform velocity. That means the gradient of the displacement time graph would be positive. And then coming back, okay, then it came 30 meters back. So the graph is going to go like this with a higher gradient because the velocity is more, but in the negative direction. So this would be the displacement time graph. This shows that the object was moving with 3 meters per second for the first 10 seconds. And this shows the object is moving with -6 meters per second for the last 5 seconds. So this would be the graph looking like for the displacement time graph, just for the sake of understanding. Otherwise, there's very much a lot more to be done. Okay, first I'll not be doing the spring constant. Before that, I would be doing some very important concepts regarding ball being thrown up and ball coming down. Over here, I've got a ball. So I brought a ball, and it's not a ball, it's basically a foam bally thingy. So it's a foam ball. So initially, in the first case scenario, I'm going to throw the ball up. So what I did is I threw the ball up and then it came down. So ball goes up and come down. Ball goes up and came down. Initially, when I threw the ball up, it actually went up. At the maximum height, it gained rest position and then it again came down. So there were two parts of the journey. First part of the journey is when the object goes up, and the second part of the journey is when the object goes down. Initially, assuming that this is zero displacement or the original position, I'm going to be making the graph with respect to this position. Initially, the object, when it was going up, the velocity of the object was reducing and it was gaining displacement. It was actually gaining displacement, and at the maximum height, it was at its maximum displacement. Just some imaginary values for the understanding point of view. If initially the object was moving at 40, the velocity after 1 second would reduce down by around 10, then it would again reduce down 20, 10, and eventually become 0. They're getting my point, because the object was very fast at the start and then velocity slowed down, and at the maximum height it gained rest. So when it comes to a displacement time graph, the graph would look somewhat like this, because the object is actually decelerating. Object is actually decelerating in the positive direction. I'm taking upward direction as positive. Initially the speed was maximum, eventually the speed reduces, and eventually it gained the maximum height. Assuming that air resistance is negligible. This is very important, guys. You have to be very focused. Air resistance is negligible. There is no air resistance present over here. So each second, assuming that the gravity is 10, but it's 9.1, just don't go in the numbers values, just understand the concept that each second the velocity is gonna reduce, and the object is basically reducing velocity, and at the maximum height, it is at the maximum displacement, but it's not moving, so graph is like a slightly a straight line. This part of the journey shows that the velocity is being reduced and eventually it came to rest. Upward direction was positive, so the velocity was reducing from positive 40, positive 30, positive 20, positive 10, and eventually came to rest. So this is the graph of a displacement time graph. It's a displacement time graph for the object whose velocity is being reduced. It's basically decelerating, and at the maximum height it actually gained rest position for a very small time. Only for this part of the journey, for this part of the journey, I'm gonna make one more asymptote just for the understanding point of view, because a lot of students get so much confused in this. This is so many times asked in the past papers, you can't realize. I'm just gonna make a straight line just for the sake of understanding. All right. So this is gonna be the displacement time graph. All right. Well, when it comes to velocity, you are pretty much sure that initially the velocity was 40, and since it was decelerating and eventually at the maximum height it came to rest, so the velocity graph is going to be like this. Just for the understanding point of view, this is 40, then 30, 20, 10, and 0. So the velocity is going to reduce, and it's going to reduce uniformly. So this is a displacement time graph. This is going to be a velocity time graph. Moving on, after once it has reached the maximum speed or maximum height, it came to rest, and after that rest position it would go down. Now, since I took upward direction as positive, that means when the object is coming down, the downward direction is going to be negative. So each second, if it's starting from 0, the velocity is going to increase but negatively. Since now the object is moving in the opposite direction, the magnitude of velocity is going to increase but negatively. So when it comes to the velocity or the displacement time graph, the object will be accelerating, but object is coming back to its original position, so this displacement is going to go down. Let's say if it went, let's assuming just it went, for example, xxx 100 meters. Now it's going to come down to its like original position, so the displacement is going to reduce, and eventually it would come back down to its original position. So this is going to be the shape of the displacement time graph. It's going to be very identical to the what it was at the start. So the displacement gained, this part of the journey shows that the object moved up, gained the positive displacement, and then this part of the journey shows that object came down and returned back to its original position. So this is basically the whole part of the displacement time graph. Now coming to the velocity time graph, guys be very focused. At the maximum height, the velocity is zero. Yeah, that's 100% fact. Now, once it has reached that maximum value of that minimum value of zero, now since the velocity is going to increase in negative, the graph is going to go like this. It's going to be identical to what it was at the start, but the graph is going to go like this. So the graph would be exactly like this. Why? Because this part of the journey shows that the object is actually decelerating towards towards the maximum height. And then this part of the journey shows that the object is like accelerating in the negative direction now. So this motion, if you realize, from this part to this part, the object is actually slowing down, reaching zero maximum height. And then once it reaches that side, it changes direction, starts to speed up, and that is basically acceleration in the negative direction. So I'm like very serious right now. This is some of the most important concepts. This is going to be like very challenging if you don't understand. This part of the journey actually indicates deceleration since the object is slowing down, and this part of the journey actually indicates acceleration since the object is speeding up in the negative direction. I'm pretty sure that this is clear. Well, last but not the least, kids, when it comes to the acceleration time graph, now I've seen a lot of students actually struggle a lot in this, When it comes to an acceleration time graph, for the first each second, realize acceleration basically means change in velocity. I'm going to do it one more time. Object was going from 40, just these are the values, imaginary for the sake of understanding. But this is very important. So when the object was going up, each second the change in velocity was -10. The object was slowing down. And when the object was coming down, even then the change in velocity was -10 each second. So the graph of the acceleration time graph is whole throughout the journey is gonna be in the negative quadrant. My kids, acceleration actually shows change in velocity. So each second the change in velocity was uniform, the change in velocity was not changing. Acceleration time graph would be a straight line. Need to remember one thing: the direction of velocity is same as direction of motion. If object is gonna speed up, if an object is going in the positive direction, velocity is positive. If an object is going to the negative direction, velocity is negative. That's for sure always. But acceleration actually refers to the change in velocity. So if an object is changing velocity negatively, this actually means, or in like gaining velocity negatively downwards, the acceleration time graph is going to be a straight line always. And displacement, well, if an object is moving in the positive side, the displacement is always going to stay positive because it's not going down. Yes, well, if this object would have like crossed this position, the displacement would have been negative, and that is what we are going to discuss in a few minutes in the next part of this sign convention concepts. But this is very important, okay? I'm pretty sure that this is understood, and definitely I'm hoping this is clear to all of you. Moving on. Now we have to discuss the concept of the ball thrown upwards, but now this time we'll be taking upward direction as negative. So if we have been to taking the upward direction as negative, the graph is going to flip. Now this is very important. Again, this is like exceptionally important. So this concept is asked a lot of times, and then the other one is asked a lot of times, but hopefully this will be clear. This is the original position. Now, since upward direction is negative, so initially there's maximum velocity, the object would start at -40. It would reduce to -30, -20, -10, and then 0. Each second, velocity of an object is changing. and it's reducing. The magnitude of velocity is reducing. Displacement time graph is going to be like this. It's going to be this, and then it's going to be this. Why? Coming to that in a bit. Okay, let me just make a line in front of you. Okay, so the displacement time graph will be in the negative quadrant. Since I've said okay, the upward direction is negative, that means if I'm moving in the negative side, my displacement covered is going to be in the negative direction. This is just the opposite of the concept that we have just done. And the velocity is decreasing. That means, and it's negatively decreasing. So the graph of the velocity time graph for the first part of the journey is going to be like this. Initially, it started at negative 40, and the velocity is reducing down and eventually coming to 0. Then, once it has reached the maximum height, let's say this is the original position. So once it has reached the maximum height, might be possible the distance is 100 meters. So the displacement would have been 100 negative 100 meters, because we are taking upward direction negative and we are considering if the object is going up, the direction is going to be negative. Okay, when the object now starts to come down, the object would reduce its displacement and eventually reach the zero value. So it has reached maximum displacement, that's negative 100 over here, and this value is going to reduce to this particular value, and eventually it would reach the ground, so the displacement would be back and zero again. When it comes to the velocity time graph, at this point the velocity would be zero and starts to increase, but since now I'm moving in the negative direction, the upward direction was negative, so the downward direction would be positive. So that in this case scenario, the object would be gaining speed, and the graph would be looking like this. So object is going to gain speed in positive direction. So the velocity, this part of the journey shows deceleration, whereas this part of the journey actually shows acceleration, since it was decelerating like when it was moving up and accelerating when it was moving down. So this is some very basic concept regarding the understanding of what do we call it, the direction motion. Okay. If I were to calculate the change in velocity, you can actually realize that each second the change is of plus 10. Like this is crazy. So minus 40 plus 10 is negative 30, and minus 30 plus 10 is negative 20, and minus 20 plus 10 adding 10 is negative 10, and then 0. Each second the change in velocity is positive 10. Each second the change in velocity is positive 10, and that shows that acceleration is going to be a straight line graph, and it's going to be a straight line throughout the journey. Because remember in the case scenario where like the object is going up and down in influence of air resistance, the acceleration is not changing. Acceleration, the pull of acceleration stays the same. The only thing that you have to actually analyze in this case scenario is what is the direction of motion. And once you have the direction of motion, you actually see if the upward direction is negative, then the acceleration will be positive. And if the upward direction is positive, that means the acceleration will be negative. So acceleration is always opposite of the direction of motion I'm moving in. So if I'm moving in the upward direction, the acceleration, and then let's say I'm moving upward direction is positive. So if the upward direction is positive, the acceleration is negative. And if the upward direction is negative, the acceleration is positive. So this is a point to be remembered. So if upward direction is positive, acceleration is negative. And this is very important because in the previous lesson we have done this as well. We threw ball upwards, we used to take velocity as acceleration as negative 9.81. That was the gravity value. So usually in usual case scenarios, we always take velocity as acceleration as negative when we're going up, and that is it. So I'm pretty much hoping that this makes sense. It's generally the concept of change in velocity. If you actually analyze the concepts, you're getting a good hang of it. I'm damn sure that you'll be done with all the concepts and all the past papers. But if you're still stuck and your conceptual knowledge is not well, that means it's gonna be like very bad. Okay. Now I'm gonna be bouncing a ball, and I'm gonna be discussing two concepts over here. And this actual case scenario is asked in your past papers a lot of times. So if I'm going to be bouncing a ball, and let's say this is the original position, starting point, original position, and assuming downward direction to be positive first. So then since the downward direction, the upward direction is positive, and the down, let's call it downward direction to be positive first. So since the downward direction is positive, object starts from rest. So I'm dropping a ball. I'm just dropping a ball. So I'm going to be like dropping a ball like this, and eventually it would gain speed. So it would start from 0, gain 10, 20, 30, 40. It's very simple. The displacement, it's an acceleration graph. So the displacement time graph would be somewhere like this. It's going to be accelerating. I think it's pretty simple for this part of the journey. And I'm going to make a line just for the sake of understanding. I'm pretty sure you would realize since it's uniform acceleration, so the velocity time graph is going to be a straight line. And since it's acceleration, the graph is going to be a straight line as well. It's all clear. Well, when the ball bounces, assuming this is like no energy is lost and it's like completely elastic collision. So, well, the ball bounces. Now, when the ball is bouncing, when the ball bounces, it's gonna change direction and it would come up. So, when the ball bounces, as the ball bounces, boom, and then it would come up, tuck, 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 and eventually at this point it would come to rest. So when the ball bounces, after the ball has bounced and flipped direction, after it has bounced, at that instant when it starts to move up, the velocity will be turned as negative. Why? Because initially downward was positive. That's why the velocity was positive. As the ball bounced and went up, now the upward direction would be negative. Since downward is positive, the other direction is must to be negative. The speed would reduce, 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 and eventually come to rest. So the graph starts from this point again, back to, I'm going to be changing it a little bit. So this graph starts again from negative and it would like go like this. Guys, this is very important. Just putting it values for the sake of understanding. So initially it is like it was accelerating and then it like hit over here the ground and then it started from negative 40 and then again it like reduces its velocity and came to rest. So this part of the journey it was accelerating and then this part of the journey it's decelerating and the velocity was increasing and here the velocity is decreasing. Why it started from negative? Because once it bounced, the direction of velocity flipped. But if you would realize the whole journey, the acceleration stayed the same. Each second the change in velocity was plus 10. Each second the change in velocity was plus 10. 40, 30, plus 10. The acceleration is not changing. So acceleration would be a straight line throughout the journey. My child, my kids, I'm pretty much hoping that this makes sense. This is very important. So it was accelerating at the first part. If I were to make a displacement time graph, then it would be a deceleration graph. It would be somewhat like this. The graph would go down and this would be deceleration. I hope this is all clear and all makes sense to you guys. This is exceptionally very important concept and this is something that I think should be learned by now. Last concept. I will ask you to like pause the video and make it yourself, and then once you've made that, and once that's done, then we can move on. Okay, now we are going to be doing downward direction as negative. This is going to be the last graph for this lecture. Next lecture is also going to be graphs and basic understanding. For the next couple of lectures, in the next lecture we'll be doing sign conventions in a different concept like these graphs, a little bit more than this, and then we'll be doing a lot of password practice. I've compiled all the password questions of graphs and we'll be discussing them one by one, what they are, what is the concept, so that any type of question when it comes to examination you'll be able to do that in 100%. Okay, So concept of ball bouncing. So the ball will be bouncing, okay, and the downward direction is negative. Very well. So if the downward direction is negative, and let's say you start off with the first. So if the downward direction is negative, that means the object is going to start from zero, and the velocity is going to be gained negatively. So it's going to be acceleration, but in the negative direction. Up. Now, if you were like seriously understand now, these are all the graphs that we have discussed in the displacement time concept. Acceleration in the negative direction, like this is everything that we have done individually in all the graphs. I'm just like compiling them up. Like I'm just combining them. Like the motion is accelerating somewhere, decelerating somewhere. It's the same thing. It's the same concept. Like what we have discussed. What is happening? Object is accelerating or decelerating. This is what we have done already. Like we have discussed this. There was a stinky person who was accelerating in this that direction. This is what we have already done. And these all concepts are with no air resistance. You need to realize that there is no air resistance present right now. Okay. All right. Object is accelerating. So yeah, this is going to be the graph for the first part of the journey. Object is accelerating in the negative direction. So yeah, this is what I've drawn already. This is the first part of the journey, and the object is, I'm very sorry. Okay, the object is just accelerating, and yeah, this is the displacement time graph, the velocity time graph, and so you can realize that the acceleration is negative in this case. Each second the velocity is gained by a negative 10, so the acceleration graph will be a little bit down. Okay, now when it bounces back, I, the moment it bounces, the moment it goes in ding and ding, the velocity changes because the direction of motion changes. So it's exact second it would be like 40, and then it would reduce down to 30, 20, 10, and 0. So the graph would first of all be deceleration, and this would be the graph of deceleration in the displacement time graph. The gradient is going to be reducing initially more and then reducing and eventually coming to 0. And for the velocity time graph, the graph changes quadrant. Why it does that? Because the direction of motion changes, velocity was negatively gained and then it would become positive. So yeah, this needs to be very clear, very clear. Still you have got some confusion, you can ask me. Okay, the last but not the least, the acceleration would stay the same. Why it would stay the same? Because if you can realize, each second still the velocity is changing by a negative 10. Acceleration does not change usually. Okay, that's pretty much it for the convention. There's one more thing. They ask in your examination, describe the motion. You have to describe the motion in 4 terms. First of all, whatever graph it is, let's say if I take this graph and they ask you to describe this graph, you would start off by saying that object is uniformly accelerating in the negative direction. The velocity is changing in a uniform rate. Then at this particular time, it like changes direction. Either it, whatever the question it has hit the ground and now it is changing direction in the opposite direction it's moving. Therefore, the velocity became positive, and then the velocity is reducing down eventually. This is deceleration, uniform deceleration, eventually coming to rest. Whatever graph that is, if you understand the concept of the graph, what the gradient is telling you, what is happening in the graph, you can easily describe any of the graph. That's not going to be an issue for any one of you. But if you are still struggling with the concepts, you need personalized attention. I'm always here to help you. Give me an email, drop me an email. My email address is given everywhere. Drop me an email. I've got some other premium lectures that I can share it with you that has got concepts even more broken up. So you can ask for them anytime. This is my email address. You can email me. I'll get back to you in a day and we can work it out. So these are all the concepts regarding acceleration, velocity, displacement for the first term. Combining it, I'm going to be combining one more class to this, and then in the next lesson we will be doing more of these graphs, more of these concepts regarding what is going to happen and how it's going to happen. And then once that is done, we'll be moving on to the past papers. So two more lectures regarding the graphs and the concepts, and then inshallah we'll be doing projectile motion. See you in the next lecture. Take care, guys. Since you're enjoying the lectures, just wanted to inform you that there are premium batches going on. That is direct way to get A's and A stars. It has got some exclusive content that is not generally available neither on the website nor on the YouTube. So you can join the batch to get your grade.